Good day, children. Coming to the last part of rational numbers. Have some patience. We can finish it off today. Okay? Right. So, already we have discussed how to locate a rational number in the number line. We have seen that if it is in the numerator you have 1, it is very easy to divide the number line between two numbers into like one, suppose example 1 by 7, 2 by 7, 3 by 7, something like that. And we also have discussed with one more example where it is numerator is not equal to 1. So there we have discussed, suppose if at all we change the denominator, what happens? Yeah, we can change the denominator, we can locate, but exact location cannot be known from it. So that's what we adopted. We try to make divide and multiply the given rational number with some other number so that we can get like the ratio to be equal to 1, and based on that we have divided this into, like we have taken the example of 2 by 3. So to make it 1, what we can do, it could be 6 by 6. That means what, 2 is multiplied we have multiplied 2 by 3 with some constant number. Okay, and then we have proceeded like finding the locating the particular number. That we have seen with two examples. With a positive integer we have seen, as well as with a negative integer we have seen that. Okay, so we have seen both positive and negative integers, how they fall on the positive side of the scale or the number line, and on the negative side of the number line. Then now it is another method which is called mean method. It is very simple and direct for us to solve it. Let us take an example like between 2 and 3. We wanted to find number of rational numbers between 2 and 3. Maybe let us find out 5 rational numbers. 5 rational numbers. Okay, let us find out 5 rational numbers between 2 and 3. So now let us draw the number line here first. This is 2, this is 3. Mean method says us, gives us, it is something like a tool. It is something like a tool to us, very easily solving without like making use of your brain to so much and then thinking logically whether this is possible or not, and then using all the basic concepts. Not necessary. It is something like a tool where you can easily operate. Well, mean method, from the name itself you can see mean in the sense mean of these two numbers, average of these two numbers, that is 2 and 3. So what is mean of 2 and 3? That is 2 plus 3 by 2. 2 numbers. So therefore by number of numbers. Sum of numbers by number of numbers. That is 5 by 2. So 5 by 2. So 2 ones are 2. 2 twos are 4. A remainder is 1. So if you put a decimal point here, it will become 10. So 2 fives are 10. 2.5. Yes, it lies exactly at the midpoint of these two. Right? 2.5. So therefore this is 5 by 2. So we got one rational number between 2 and 3. Got it? Now next rational number. Now find mean between these two. You will get somewhere here. And now find mean between these two. You will get somewhere here. Shall we find it out? So now see. Mean of 2 and 5 by 2. Mean of 2 and 5 by 2. So that is sum of the numbers 2 plus 5 by 2 by 2. Number of numbers is 2. See, this is 2 by 1. This is 5 by 2. First simplify the numerator part. In the numerator you have fraction. So you need to take the LCM. Here it is 1. So LCM is 2. And 2 twos are 4. 4 plus 5, 9. That is by 2 again. So 4 plus 5, 9 by 2 into 1 by 2, which is equal to 9 by 4. And this is here, 9 by 4. And now between 5 by 2 and 3. Mean of 5 by 3 and 3. So that is 5 by 3 plus 5 by 2, sorry, 5 by 2 and 3. It is 5 by 2 plus 3 divided by 2. LCM is 2 in the numerator, so therefore 2 3s are 6. 5 plus 6 by 2 into 1 by 2. So that is 11 by 2 into 2 is 11 by 4. So this is 11 by 4. So I have determined 3. Okay, so let us take this example as 3 right now because I don't have much place here to solve. And if it is asked for 5, you can find between these two somewhere here. You can find between these two somewhere here. Between these two at the midpoint. Between these two at the midpoint. Multiple rational numbers. So many rational numbers you can find between these two just with mean method. So there won't be any confusion saying whether my approach is right or no, wrong, whether I am thinking it properly or not. So there is no worry at all when you adopt this one. The only thing you have to remember is that whenever you are doing it in numerator, when you find the ratio, you have to take the LCM and then determine the values. That is very important. That though you know very well. Okay. So this is how to find out rational numbers between two numbers using mean method. Using mean method. Right. Average of the two lies exactly at the midpoint of the number line between those two numbers. So here between these two it is a midpoint. Between these two it is a midpoint. And between these two another midpoint you can find out finding the mean. Number of you can determine. Okay. So number of things you can determine. Now coming to the next part. The most important part, which we call it as decimal form of integers. Right. So now from fraction to decimal. Fraction to decimal. So because why we are taking fraction here? Because it's very easy definition. P by Q, Q not equal to 0. Any number which is represented like this is of course a rational number, undoubtedly. So I'll take it as 3 by 2. Let us do. 2 ones are 2, 2 ones are 2, remainder is 1. Put a point here, that 1 will become 10, 2 fives are 10. So 1.5. So fraction is converted into 1.5. So now let me take 5 by 3. So 3 ones are 3, 3 ones are 3 here. Now 2 is the remainder. Put a point here, 2 will become 20, 3 6 are 18. Again 2 remainder. Since you have put a point here, that will become 20. 6 times 3 6 are 18. Again 2 is the remainder, 6. Like that 1.6666666. So how are you going to write it as? 1.6 bar. What do we call? 1.6 bar. We are writing it as 1.6 bar. That means 6 is repeated periodically. So what is the periodicity here? 1 is the periodicity. Periodicity. What is meant by periodicity? How many decimals are repeated? Here only one decimal is repeated. That is 6 is one integer is digit is repeated. 6, 6, 6, 6 always. So the periodicity of this 1.64 is 1. 1.6 bar is 1. Periodicity of 1.6 bar is 1. So 6 is only repeated number of times. So only one digit after the decimal point is repeated. So hence we call that to be periodicity. We call that to be periodicity. Right? So suppose if you have a number like 0.32, 32, 32. Suppose if this is the decimal number which is given to you. Okay, so what is repeated? 32. So 32 is repeated. So I can write this whole thing as just like this, 0.32 bar. 32 together is repeated. 32 together is repeated here. So it is 0.32 bar. It is 0.32 bar. How many digits are repeated after the decimal point? It is 2 digits. So therefore what is the periodicity here? 2 is the periodicity. So this is how you can convert. That means by just doing division. This is a simple division. You can go by long division method. Suppose if you can't do like this, but better you practice doing like this. Okay. Let us suppose if you wanted to do in long division method. I will take 25 by 3. Okay. Let me take 25 by 3. What happens? Let us see. So 3. 3 8s are 24. Very good. Subtract. 5 minus 4 is 1. 2 minus 2 is anyway 0. So only 1 is a remainder. Put a point here. So it will become 0. So 3 3s are 9. 3 3s are 9. Again 1. Again 3. So like this. So this will continue. So what is that you got? 25 by 3 is equal to 25 by 3 is equal to 8.3333 and so on. And so on. So thus you can write it as 8.3 bar. So in 8.3 bar, what do you have the periodicity to be? 1. You have the periodicity to be 1. Right. So this is like from fraction to the decimal. This part you have done it in your previous classes. But the only thing here is now we are going to check whether they are rational numbers or not. What is the condition for decimal point to be rational number, decimal numbers to be? One thing what we have to see is that it should be terminating. See, it is terminating. After 5 nothing is necessary because there is no remainder here. 1.5 finished, ho gaya. So it is terminated. Now this is non-terminating. See, it is not terminating. 6 is continuing like that. Continuing. So if it is non-terminating, we are not going to conclude it as not rational. How are you going to check the next step? Whether that is recurring or not. That is a repeated digit or not. So this is repeating here. So recurring. So therefore this is rational number. This is a rational number. This is a rational number because 3 2 is repeated here. Right? So this is how you can convert fraction to the decimal. Fractional rational number to the decimal rational number. This is the periodicity. That means the number of digits that are repeated after the decimal point is called periodicity. Here in this case 6 is repeated. Only one digit is repeated. So 1 is a periodicity. Here only 3 is repeated. So only one digit is repeated. So 1 is a periodicity. In this example 3 2. Both the digits are repeated. So 2 is the periodicity. So what is the periodicity? 2 is the periodicity. Right, now the point here is, suppose if you are given in the decimal value, how are you going to convert into fraction value? Okay, let me take the examples. Right, 25.4. I am given a number 25.4. How to do it? See, after the decimal you have one digit. You can just divide, remove this decimal. How many digits you have after the decimal point, those many zeros you can put beside 1 in the denominator. This means it is 25.4 by 1, is it not? So now this one, I am going to eliminate this decimal, right? Just remove the decimal and excuse me, and count number of digits after the decimal. Here only one digit. So 1 0 comes here. Okay, now 2.54. Of course, nothing is there means it is by 1. Now here, after the decimal you have 2 digits. So remove the decimal first. Write 1 as it is. How many digits you have? 2. So 2 zeros. Okay. Furthermore also you can simplify because this is an even number. This is also an even number. You can say like 2 5s are 10, so 2 1s are 2, 2 2s are 4, 2 7s are 14. So it is 127 by 5. So this is the decimal number which is given to you. 25.4 can be converted into 127 by 5. That is how you are going to convert it into fraction. Okay, that is how you are going to convert it into fraction if terminating digits are given, terminating decimal values are given. Very easy to convert. Directly you can convert it into fraction like this. Okay, so now suppose if it is 0.12, right? 0.12 is given to me. Let me write it down. So after the decimal point, it means that by 1 is there always. So by 1 as it is. Eliminate this one. When you are eliminating the decimal point, you have a 0 on the left hand. So no need, extreme left 0, no value. So you are going to write 12 as it is. How many are there after the decimal point? 2 digits, so put 2 zeros. 12 by 100. Both are even numbers. 2 50s are, 2 6s are. Right, again what you can say? 2 25s are, 2 3s are. So you got it to be 3 by 25. It is 3 by 25. Okay, right. So now similarly here also you can do it. This is also even number. I am leaving it to you. You can solve and then post it to me. So this is how you can convert the decimal. Which decimal numbers I am saying? Terminating decimals, where there are no other digits after this. With this only we are getting the final value. Yes, with this only we got the value 127 by 5. With this only we got the value 3 by 25. Okay. So whenever terminating decimals are given, so this is how that means. Just you have to convert that by removing the decimal point and adding number of zeros in the denominator. That's all. Obviously you will get clearly the fraction, equivalent fractional value for this decimal rational number. Okay, decimal numbers here are terminating decimal numbers. Therefore, they are rational numbers. This rational number can be expressed in the form of P by Q always. This is what we were learning since 2 weeks. So, therefore, it is P by Q. P by Q. Q not equal to 0. Okay, pause the video for a moment and copy it down. So now the next part is converting non-terminating. Just now we have seen if it is terminating decimal, you can just remove the decimal by adding number of digits which are there after the decimal in the denominator. How many zeros? Number of digits, how many digits are there after the decimal point? Those many zeros we are adding just beside 1 in the denominator. Thus we can just convert the decimal value into the fraction. Here it is non-terminating. Non-terminating and recurring. Then only it is a rational number. Yes? Then only it can be expressed as P by Q form. Clear? Then only. That is very, very important. If it is non-terminating and also non-recurring, that cannot be expressed as P by Q. Please remember, that is irrational number. That is called irrational number. In the next classes, that means in the higher studies, you will be learning about that. Okay, rational means if it is at all terminating, non-terminating, it should be recurring. If it is not recurring, it will become irrational number. So we are going to now see that if it is non-terminating but recurring decimal, how to convert it into fraction. Let us do 2 examples here. Example 1, 0.3 bar. What is the periodicity? 1. Here periodicity is 1. Here periodicity is equal to 1. So now to solve this, there is again a method for you. Very easy, nothing to be worried about. Now let us take the given number as x is equal to 0.3333 etc. Yes or no? Absolutely, because 3 is repeated. Right. Now since periodicity is 1, we are going to multiply this x with 10 times. Now I am taking 10x. 10x means 10 times of this. 0.3 into 10 is 3 point. Next again, all the 3's will get repeated. 3. How many 3's here you take? No? Those many you take, so that it will be easy for you to further simplify. Clear? Right. So now we have x is equal to 0.333, that is 0.3 bar. 10x is equal to, of course, 3.333 because we are multiplying this with 10 times. So 3.333. Now let this be equation 2 and this be equation 1. Okay? Let us not cross our limits. Right. So now doing equation 2 minus 1. So what do we get? So first we will write 10x is equal to 3.333. Then x is equal to 0.333. Subtract this one from this. Subtraction. 10x minus x is 9x. 3 minus 3 is 0. 3 minus 3 is 0. 3 minus 3 is 0. 3 minus 0 is 3. 3.00, which is equal to 3. Right? So 9x is equal to 3. or x is equal to 3 by 9. X is equal to 3 by 9. It can be further simplified. 3 ones are 3, 3 threes are 9. 1 by 3. But what is x, sir? X here is 0.3 bar. So therefore 0.3 bar can be written as 1 by 3. So simple, see? Very, very easy if you people understand it. Point here is, why are we taking these many 3's? Because they'll get cancelled, so we'll get an integer value here. Okay? Then only you can like convert it into fraction. Simple logic. Because how many 3's we want, we can take. Because 3, 3, 3, 3, 3, 3, 3 like that, right? So to make ourselves, to make the problem very easy or simple, you are not going to take this. So that this decimal part will get eliminated. We have to eliminate this, no? If not, you can't convert it into fraction. So for eliminating, how many 3's you are taking here? Those many 3's after decimal, you also take in the multiple of x. How many times we have to multiply? 10 times or 100 times or 1000 times? This depends on the periodicity. This depends on periodicity. Periodicity here is 1. Only one digit is repeated. Multiply it with 10. So you are taking the given value as x. X is equal to 0.3333 and so on. 10 times of x. 10 times of 0.33. So 0.3 into 10 is 3. 3 point. Again 3, 3, 3, 3. How many 3's you want, you can take. But we wanted to eliminate this decimal. So how many 3's you are taking here? Please after the decimal point, those many 3's only you take. So now, let this be second equation. This is first equation. 2 minus 1. Do that. 10x is equal to this. X is equal to this. Subtraction. 10x minus x is 9x. 3.333 minus 0.333. These 3's will get eliminated. And 3 minus 0 is 3. So you got 9x is equal to 3 or x is equal to 3 by 9. Here what is that? Further you can simplify. 3 ones are 3, 3 threes are 9. So that is equal to 1 by 3. Thus what is x? X is 0.3 bar. Is it not? 0.3333. So 0.3 bar is equal to 1 by 3. So easy. Now let us do the same with periodicity 2. What should you do? Yes. Here you have to multiply with 100. Okay. Here periodicity is 2. So therefore let x is equal to 0.2525 dot. Now periodicity is 2. Therefore I want to multiply with 100. 100x is equal to 2 zeros are there. Means after decimal point 2 will shift here. 2 digits. 25.2525. So how many you are taking here? Those many you take here also. Right. Now let this be equation 2. Let this be equation 1. Now do 2 minus 1. Equation 2 minus equation 1. When you are putting it in the, circles, it means that equations. You can't write 2 minus 1. 2 minus 1 is 1. So equation 2 minus equation 1. What does it give to us? 100x is equal to 25.2525, where x is equal to 0.2525. So now this will get eliminated. 25 minus 0 is 25. 100 minus x is 99x. 99x is equal to 25, or x is equal to 25 by 99. It can't be further simplified. So we leave it like that. But what is your x? X is 0.25 bar. 0.25 bar is equal to 25 by 99. See, beautiful concepts, na? Very, very beautiful. I don't know who is that who worked on all this and gave us such simple methods in solving things, right? Hats off to them. Okay, so now if periodicity is 3, you have to multiply x with 1000. 4, 10,000, like that. Okay, clear? So please pause the video, copy this. With this, rational numbers is done. Okay, and now it is your job to check whether you have done all the exercises or not. Exercise based on this I am going to post after this class, and then you have to solve those problems and check the whole chapter. Go through everything from the beginning. If you want, you might have already have the links of all the videos. You can go through the video again one after the other, so that again concept will be clear. Thus, next we are going to have a test in this. So I'll announce you the date when you have to write the test. So please copy this, do the exercise, post me your doubts if you have any, and then go through the whole topic, listen to the videos again from the beginning, complete rational numbers, be clear with the concept. You should have a crystal clear approach in every step why you are doing, why not in the other way, right? So practice and then get ready for the exam, right? Done.